The headline says 1,000 kilometers per hour. The viral footage shows a sleek capsule streaking through a glowing tube beneath the ocean. Western tech blogs run the headline, "A Chinese submarine train will change travel forever." 623 kilometers per hour confirmed in test. A 60-kilometer track under construction. A subsea tunnel 16 kilometers long, 78 meters below sea level, drilled by a tunnel boring machine the size of a small apartment building. The footage is real. The construction is real. The state backing is real. But there is no submarine train. What there is two completely different Chinese mega-engineering projects run by two separate state conglomerates on two separate continents of physics. The English-language press has welded them into a single viral headline. The 1,000 km/h figure belongs to a vacuum maglev test track in landlocked Shanxi province. The undersea construction footage belongs to a 250 km/h conventional electric train in coastal Zhejiang. They have nothing in common except the word Chinese. What is actually being built is more interesting than the headline, and what is currently impossible to build by the actual physics is more interesting still. Welcome back to the channel. We are going to walk through the so-called Chinese submarine train the way it actually looks at the planning desk, not the way it looks in the viral feed. The argument rests on three claims. First, that there is a 1,000 km/h underwater train. Second, that China is on the verge of operating it commercially. Third, that this represents an inflection point in the global transit race. We are going to grant that two real world-leading Chinese infrastructure projects are happening right now. And then we are going to show you why the headline is a translation artifact, why the marginal economics of 1,000 km/h are far weaker than the framing implies, and why the project that will actually change Chinese travel is the slower, less glamorous one. Start with the disambiguation. Project 1 is the CASIC T-Flight. CASIC is the China Aerospace Science and Industry Corporation, a state-owned aerospace and defense conglomerate. The T-Flight is a vacuum tube magnetic levitation system being tested on a 2-kilometer track in Datong, Shanxi province, 500 kilometers inland from the nearest coast. In February 2024, T-Flight reached 623 km/h in non-vacuum conditions. CASIC is now expanding the corridor to 60 kilometers, with a target of 1,000 km/h and a long-range simulation goal of 4,000. It is terrestrial. It has zero underwater implementation. Project 2 is the Jintang undersea tunnel, the centerpiece of the Ningbo-Zhoushan high-speed railway in coastal Zhejiang. It is a 16.18-kilometer subsea shield tunnel with 11.21 kilometers running under the seabed, descending to 78 meters below sea level. It is being drilled by two super-large diameter tunnel boring machines named Dinghai and Yongzhou. Dinghai alone is 14.57 meters in diameter and weighs 4,350 tons. The two machines began boring from opposite coasts in May 2024 and must converge with less than 20 millimeters of alignment error. The tunnel is engineered to carry conventional electric high-speed trains at 250 km/h. Opening is projected for 2028. This is the world's longest planned undersea high-speed rail tunnel. The third element is the seabed vacuum tube, an academic concept developed by engineers at Southwest Jiaotong University and Dalian University of Technology, modeled for theoretical sea-crossing corridors of the Bohai Strait and the Taiwan Strait. It is a peer-reviewed research paper, not a funded program. The fourth is the Bohai Strait Tunnel, a long-proposed conventional high-speed rail link between Dalian and Yantai. The estimated cost moved from 200 billion yuan in 2014, roughly $32 billion, to over 300 billion yuan by 2019, or $43 billion. Plans were submitted in 2019. No construction has begun. So when the headline says, Chinese submarine train at 1,000 km/h, it has fused the speed target of Project 1 to the underwater geometry of Project 2 while invoking the academic concept of Element 3 to make the welding sound credible. Both real projects sit inside a state-driven industrial architecture. The institutional split is the centerpiece. CASIC owns the T-Flight. The technological lineage is aerospace, not railroad. Vacuum tubes, pressure vessel design, linear synchronous motors, electromagnetic suspension, these are aerospace disciplines. The Datong facility is funded by Shanxi provincial authorities and state bank financing, positioned as an aerospace technology demonstrator. CASIC is currently the only state-backed actor in the world, advancing a vacuum tube Hyperloop concept following the bankruptcy of Virgin Hyperloop 1. CRRC, the China Railway Rolling Stock Corporation, owns everything else. CRRC and the China Railway Infrastructure Bureaus, specifically the China Railway 14th Bureau Group on Jintang, operate the world's largest active rail network. They built the 45,000-kilometer high-speed rail backbone. The CR450, unveiled in early 2025, runs commercially at 400 kilometers per hour with a maximum of 450. Jintang sits inside this ecosystem, not the aerospace one. In February of this year, China deployed its first deep-sea space station inside the Jintang tunnel at 75 meters depth. This is a saturation pressurized work cabin filled with a ternary mixed gas, helium, nitrogen, and oxygen, engineered to allow human workers to inspect and replace cutter tools on the boring machines under 0.85 megapascals of external pressure. That is the equivalent of 30 kilograms pressing on a single coin. 46 cutter tools were replaced. This breaks the previous safe operational depth limit of 60 meters. The vacuum Maglev is an aerospace project marketed as transit. The undersea tunnel is a transit project that has quietly become deep-sea engineering. The state mobilizes both pipelines, but they are not the same pipeline. China now operates the most credible state-backed vacuum transit research program in the world by default. Virgin Hyperloop 1 liquidated in 2023 after burning roughly $450 million across nearly a decade. The American Hyperloop industry is functionally extinct. CASIC is the survivor, by attrition rather than triumph. The second-order implication is on conventional rail. Jintang, operational in 2028, will be the world's longest undersea high-speed rail tunnel. Combined with the proposed Bohai Strait crossing, China is building a continuous high-speed rail spine from the inland west to the maritime east, including across previously uncrossable salt water. That is the actual transformation. The third-order implication is geopolitical. China's industrial architecture lets it run two parallel megaprojects with two separate state conglomerates without either having to economically justify itself. As rail analyst Mark Smith noted after the T-flight test, quote, "If anyone can make this work, it will be the Chinese. They have the clout, and they don't have to worry about things like cost-benefit analysis." End quote. The state capacity to execute is the message. That is the threat case. Here is what the headline skips. First, the verification gap. There is no Chinese submarine train. The 1,000 km/h figure belongs to a land-based aerospace test track. The underwater construction belongs to a 250 km/h conventional rail tunnel. Apply the standard 3 to 5 year discount on Chinese aerospace timelines that have not yet broken ground. Second, the Hyperloop graveyard. Virgin Hyperloop 1 spent $450 million and never carried a paying passenger. The failure mode was thermodynamics. Vacuum pumps consume continuous power. Steel tubes expand and contract. Airtight seals degrade. Maintenance cost grows exponentially with track length. The laws of thermodynamics are constant. Third, the marginal utility problem. Peer-reviewed analysis in the International Journal of Sustainable Transportation models speed upgrades on a 500-kilometer route. 300 to 500 saves 39 minutes. 500 to 700 saves 16.2 minutes. 700 to 1,000 saves only 7.5 minutes. The Jintang tunnel will reduce a Ningbo to Zhoushan crossing from a 2-hour drive to under 30 minutes at 250 kilometers per hour. Pushing that to 1,000 saves another 20 minutes at multiples of the cost. Fourth, the seismic geometry. The Bohai Strait, the Taiwan Strait, and the East China Sea sit inside highly active fault systems. A rigid vacuum tube cannot tolerate millimeter-scale deflection because the capsule is traveling at near Mach 0.8 inside a sealed near vacuum. A minor earthquake produces a millimeter-scale wall flex, and the capsule strikes the wall at supersonic velocity. Damping is incompatible with the structural rigidity that 1,000 km/h transit demands. Fifth, the catastrophic failure mode. In a sealed vacuum tube at 70 meters depth, a single hull breach lets seawater enter a vacuum. The pressure differential accelerates that water to supersonic speeds inside the tube. The lateral hydraulic shock destroys the infrastructure faster than automated bulkheads can deploy. The proposed mitigations exist in academic papers and nowhere else. Sixth, the export ceiling. T-flight depends on high-temperature superconducting materials, advanced electromagnets, and rare earth components. Western nations are aggressively de-risking critical infrastructure supply chains away from Chinese sources. Without export, the unit economics never reach the scale required to lower domestic construction cost. And seventh, the propaganda lag. The C929 widebody, the ARJ-21, and several Chinese military aviation timelines have slipped 3 to 5 years between state media reveals and operational service. Treat 1,000 km/h subsea maglev claims through that lens. So the honest answer to whether the new Chinese submarine train will change travel forever is, there is no submarine train. There are two real projects on two separate roads, and the road the headline is selling does not yet exist. On one road, CASIC scales the Datong corridor from 2 km to 60, validates T-flight at 1,000 km/h in genuine vacuum conditions, and the Chinese state designates the Bohai or Taiwan Strait as the first commercial subsea vacuum corridor. It requires solving the seismic deflection problem, the catastrophic failure problem, and the marginal utility economics simultaneously. The probability is non-zero. It is also very far from 1. On the other road, Jintang opens in 2028 as the world's longest undersea high-speed rail tunnel. The Bohai Strait crossing, eventually approved as conventional rail rather than vacuum experiment, follows in the early 2030s. Travel times collapse from hours to minutes for hundreds of millions of coastal Chinese commuters. The Datong T-flight remains a test track. On this road, China changes Chinese travel. It does not change global travel. The actual measurable picture is two world-leading Chinese transit programs running simultaneously. One aerospace research, one transit infrastructure. The aerospace project will not be commercial this decade. The transit project will be operational in 2028. The construction is real, the submarine train is not.